Hello guys, my name is German Viscuso and I'm a technical evangelist working for Amazon, specifically with the Alexa technologies. I come all the way from Madrid to give you this talk, and I want to talk about how Alexa is getting smarter. This is like a basic talk. We are not going deep into any machine learning technology, but I hope you will have an understanding of what's going on behind Alexa, especially with those aspects that are not so obvious. You probably never heard about some of these things before. So thanks for being here. I know there was a really big party yesterday, so I hope you had a great time. But I also hope that you pay attention now, okay? So let's get started. So this is the inspiration for Alexa. Basically, this is the Star Trek bridge. If you saw some of the episodes, you saw that there was a computer where you could basically talk to the computer from anywhere in the ship. Basically, it was natural. You could say whatever you want. The computer was already listening for your utterances or your phrases, and basically would get back to you naturally in a conversation kind of style, right? So this was the inspiration, but the inspiration is not enough. You might have a really nice inspiration, even a science fiction kind of technology, but you need to have the necessary pieces there to make it happen, right? So the three things that allowed us to make Alexa to create Alexa were three things. One of them was the rise of the machine learning technologies. So basically, machine learning got to a point, especially on the deep learning side, where it was it was practical to come up with algorithms that could basically solve really hard problems, like problems related to voice, like ASR, automated speech recognition, and NLU, natural language understanding. So the technology got to a point where we can use machine learning technologies to effectively solve a very, very hard problem. Okay. So the second trend, which allows us to create Alexa, is the rise of cloud computing technologies and the power that you can have access to nowadays when it comes to cloud computing. Those algorithms that I mentioned, the machine learning algorithms, are nothing if you cannot run them on scale, in a super scalable fashion. Because if you consider Alexa is processing billions of phrases or utterances per second, right? So if you don't have this kind of infrastructure, it's very, very difficult to basically create this type of technology. Nowadays, you can have access to AWS services, for example, in a super scalable way, and basically you just need to pay for the services, right? There are multiple regions, etc. The third thing that was super important to us was the evolution of user interfaces. So about every decade, we see that there's a paradigm shift in user interfaces, and in the 70s, around the 70s, we started with character-based computers. Then we switched into graphical user interfaces, one more decade, and then the web appeared, and we needed to optimize those user interfaces to basically serve those buttons and those windows in a really, really fast way. And then it came the touch user interface with the mobile phone. Okay, so this is the decade for voice user interfaces because they are natural, they are easy to interact with, and we are basically wired for speech. We don't need to learn a new user interface. Okay. So every time I talk about innovation around Alexa, people immediately start thinking about the devices, right? And the devices that we are putting out. This is one of the latest iterations. We announced 14 products like last month. And if you remember last year, around the same time, we also announced another 14 products, including the Echo Show. So we usually have like a fall event where we announce a lot of devices. But this one, this is the last one, is particularly interesting because you can see that the idea seems to be to put Alexa everywhere. You can see that we have a ring there that you can wear, and talk to Alexa. We have glasses, it's called the Echo Frames, where you can have Alexa in your own glasses. And we also have Echo Buds, where you can wear specific headphones and talk to Alexa all the time. So this is no longer about having Alexa at home, but it's basically having Alexa everywhere, okay? So innovation On devices is not the only thing that we are doing. Consider the fact that there are more devices being put out by third parties rather than Amazon, right? So the thing that we are really proud about is the technology behind Alexa and all the machine learning technologies that we're using. We are known for these technologies, okay? Which is basically the core machine learning technologies behind Alexa. We are doing ASR, which is basically translating sound into text. Okay, it's called automated speech recognition. We are also doing NLU, natural language understanding, which is basically getting a meaning out of what the user is saying. Once you have that text, you need to basically understand the context of what the user is saying and understand what you need to do. If you need to open a skill, if you need to call a 1P feature of Alexa, etc., right? And also, we are doing TTS, which is when you create a response from your skill or from a third-party skill or from a skill from Alexa. You need to craft a response, and you usually do that via text. And then you send it back, and there's a process called TTS, text-to-speech, that would transform that text into sound, right? Into Alexa basically talking. Okay? But these are the technologies that you can see in any of this type of technologies, okay? Everybody's doing that, doing this when we're talking about this type of technologies. But what about other ways in which we're using machine learning? And this is what I want to talk about today. How we are applying machine learning across multiple problems to basically solve and make Alexa smarter. And solve this specific problem of making Alexa understand what you're saying and be more intelligent, okay? So let's talk just briefly about ASR, automated speech recognition. Automated speech recognition is a core technology of Alexa, but it's a technology that has had an incredible an inflection point about 2010. Okay, so this technology, we were applying traditional algorithms every decade, the 70s, the 80s, the 90s, etc. But we were only getting marginal returns. 50% human accuracy, 55% human accuracy. Human accuracy, the dotted line there would be understanding what somebody else is saying at the human level. Okay? So thanks to machine learning around 2010, we got to 95% accuracy. So in just 10 years, let's consider 2010 to 2020, in just 10 years, we achieved much more than what we've been able to achieve in 4 decades, in the 4 previous decades. Okay? So right now we are in a position since the dawn of AI to basically talk to our machines and have them understand what we're saying. Okay? So let's move on. Self-learning. This is one way in which we are innovating on machine learning. Self-learning. Supervised learning doesn't scale. When you do supervised learning, you need to basically label information. And if you're processing billions and billions of requests and you need to label that, that doesn't scale. So we need ways to actually make Alexa learn automatically. Okay? And this is a way in which we are doing exactly that. Suppose that someone remembers that there's a song that goes by ABC in the lyrics. And that person remembers that as the ABC song. But that's not the real name of the song. The actual name of the song is the alphabet song, for example. So the user would say, play the ABC song. And every once in a while, we would tell Alexa to ask, to make a guess on what the music that should be, what the song should be. And once Alexa asks for that information, the user starts providing feedback, like saying, yes, that's the song that I wanted to open, or no, that's not the song that I wanted to open. So we collect that information, okay, and we start collecting that information, and then we know whether our guess was right or it wasn't right. And in this way, we are allowing Alexa to basically learn how to open the right song, even if you did not mention the right name. And this is very powerful because you don't have to be 100% accurate in how you ask for things, right? And this is one of the ways in which we're innovating using machine learning. But there are many other ways and many other processes, and I'm going to mention a lot of them today. So let's talk about context awareness. So context awareness is understanding the who, what, when of what's going on, right, of a conversation. If you think about it, when we have a conversation with a friend, etc., if we don't have context, we cannot really keep the conversation, right? We are not handling the right information. So let's take a look at this example. In this example, as you can see, there's one utterance there where the user is asking for the weather in Hamburg. Okay, so what's the weather like in Hamburg? That's a very straightforward utterance, very easy to understand. We're talking about the weather, we have an intention, an intent, and we're talking about Hamburg, we have an entity. We know where we want to find out about the weather, right? But take a look at the second utterance over there. What about tomorrow? Consider that phrase, what about tomorrow? Are we referring to Hamburg? No. Are we referring to getting to know the weather? No. So basically, that's a very specific utterance that tells me nothing. If I don't have context, tell me nothing about what the user really wants to do. It's super important for us to keep context. And we are innovating a lot in that area. As you can see there, we are using a specific neural network called long short-term memory networks, which are a really special at handling time series information, and they can basically store information across multiple interactions and basically keep those entities and those intents and understand what was going on before we got into that phrase, what about tomorrow? So we keep a history and we feed back that information into the loop again. So when we get that kind of utterance, we know that we're talking about Hamburg, and we know that the user wants to find out about the weather, okay? But tomorrow, obviously tomorrow, not today.
Rough day. What's for dinner? Shh. Alexa, open Domino's.
Hi, welcome to Domino's. Would you like to place an order or track an order?
So this is another way of understanding context. There's a very specific context in this interaction, which means that the user is basically trying to be not so loud, and we are detecting that pattern, and we are answering back in whispers, okay? So we call that whisper mode, and it's also a way to provide context awareness, and we are using the same kind of networks that I mentioned to basically model the acoustic pattern of the people talking in that way, okay? So when we detect that, we have a special TTS process, text-to-speech process, that will create that sound wave of Alexa answering back, also whispering, okay? And both of these processes, the detection process and the generation process, are using machine learning and neural networks specifically. We are not detecting, like hard coding the pitch detection for how the user is talking or things like that. This is all done via machine learning, okay? Another way, these strange graphics are called Mel spectrograms, and I'm going to talk about them later. So basically, they model a time series for a sound, okay? So another way to provide context is basically understanding what's going on when we are not home. Suppose that the system that we have on the device to detect the wake word, you probably heard about the wake word. When you say Alexa, the device wakes up, right? That's the wake word. We have very specific machine learning models running on the device to detect the wake word, okay? So we did some experiments where we prepared those neural networks to detect very specific patterns of sound, meaning distress within the house. Like, for example, a glass breaking or a smoking alarm being turned on. If we detect those patterns, we send a notification to the user. This is running in the US right now, okay? And we did have to break a lot of different type of glasses to actually train this neural networks. So, context beyond words. You might say, Alexa, I am leaving, and Alexa might prepare your house in the right setting because you're leaving, right? So you don't have to say, turn off the lights. You don't have to say specific things. Basically, Alexa understands that because you're leaving, there are a few things that have to be done. We have a technology called Alexa Hunches. And Alexa Hunches is a technology that will give you hunches based on what you're doing. For example, this person is leaving, and suppose that the lights are turned on, and Alexa will give you a hunch and say, hey, you're leaving your lights on. Do you want to turn them off? Okay? So Alexa becomes more proactive and more intelligent with this type of technology. If you want more information, just search for Alexa Hunches, and you will see other examples. Okay? So the technology that I mentioned about detecting specific sound patterns, like like glass breaking and alarms, we call that Alexa Guard. Alexa Guard, and it's something that we will be rolling out progressively in different locales. So let's think about how we make Alexa more natural. Okay. So we need to make Alexa more natural across different areas. So let's start with one right now. And let's start with having a more natural skill interaction. Usually when you open a skill, you have to say, ask Ola to give me a cab, or ask Uber to send me a ride, or something like that. What if you could say, Alexa, book me a cab, right? That would be much more natural. And we are working with a very specific technology. We call it the NLU shortlister. NLU is Natural Language Understanding, which is basically a ranking and selection algorithm to find out what is the right skill for a specific request. So you won't have to say, open a specific skill anymore with this type of technology, but basically Alexa will make the best guess at what is the right skill that it should open. And this is super important because I'm going to talk about a technology called Alexa Conversation by the end of Alexa Conversations by the end of the deck. And I want you to have this in mind, like how skills can interact and how skills can basically provide information about what they can do. So for example, when you say, Alexa, book a cab, Alexa needs to know if your skill, suppose you're a skill developer, if your skill can actually provide a cab ride, right? So that metadata has to be within the skill, and it's going to be very useful for some sorts of very clever interactions that we will take a look at. This is, by the way, also using machine learning, okay? That NLU shortlister is using machine learning to make that selection. So another way in which we're making it more natural is basically when you are dealing with your lists. Suppose that you say, Alexa, add peanut butter, add apples, peanut butter, and jam to my shopping list. That would translate into one entry in your shopping list not long ago, right? So we are being much more intelligent now at being able to partition those items into also using machine learning, so we understand that they are different items. It seems trivial, but it's not. Because if I said peanut butter, peanut is something that is standalone, could be standalone, and butter is something that also could be standalone, right? So you have to have some context to understand that we're talking about something that is a whole thing, like peanut butter. So it's not as easy as it seems, okay? Multiple intents in one shot. If you have Alexa right now, who has Alexa? Oh, that's a lot. That's awesome. So if you interacted with Alexa, you know that you can ask for one thing, basically. You can ask to play a song, or you can ask to turn on the lights, or you can ask for something else, but you cannot ask for two things at the same time. So we are working on this problem, working on a coordinator machine learning technology that would actually allow you to ask for multiple things, and we will be able to partition those things and understand that you want to do 2 or 3 things at the same time. Okay? This is ongoing, and everything that I'm mentioning today is not only like a proof of concept research, but it's being turned into specific products. Most of these are already released in the US, okay, to give you an idea, and then rolling out into different locales. So we are not talking about something that is like up in the air, right? We're talking about something very concrete that is working, okay? Text-to-speech, TTS. So we are working really hard on a technology called Neural TTS. Neural TTS is a technology that instead of using concatenative technologies to create sound. What is concatenative technologies? It's basically you get small pieces of sounds, put them together, and you form a word. Then you put more pieces of sound there, and you form a sentence. So that's how this technology works traditionally. Basically, you're doing a copy and paste of very small pieces of sounds to basically form, what Alexa is saying. But this is a completely new technology, and it's a technology that's going to change everything, and you will see why in the next few slides. So this technology is basically using a neural network to generate the audio, the spoken audio, from scratch. So it's a complete from-scratch model that takes specific speaking patterns, specific styles, specific emotions, etc., and it would generate audio based on that. So it's a neural network, okay? And that's super powerful, and you will understand why immediately. This is how Alexa used to talk in 2014 with concatenative technologies.
Star Trek is an American media franchise based on the science fiction television series created by Gene Roddenberry.
Did you hear like the artifact in Roddenberry? It was like Roddenberry. That's very strange, okay? Now let's take a look at the same phrase using neural TTS.
Star Trek is an American media franchise based on the science fiction television series created by Gene Roddenberry.
Doesn't it sound much more natural? What do you think? Okay, so the technology to actually generate those neural networks is a little bit complicated, okay? But let's put it this way. We are using MEL spectrograms, which is a representation of the audio. We are using speakers and specific styles of speaking to train those neural networks. So we can train it based on a specific speaker, okay? And then we can generate a neutral model based on those speakers that is more independent, that can actually generate audio from scratch. So the input of this neural network will be text, and the output would be someone speaking, but following a very specific training pattern, okay? From scratch. So let me show you an example here.
San Francisco's $2.2 billion Grand Central Terminal open. Spanning 3 city blocks, San Francisco's $2 billion transit terminal is open. This is after nearly a decade under construction.
This is traditional concatenative technology. This is not neural TTS. And now you're going to hear the same sentence in neural TTS, using a speaker style that we call the newscaster style, which is a style modeled after someone speaking on TV, okay? Like the typical news person speaking on TV.
San Francisco's $2.2 billion Grand Central Terminal open. Spanning 3 city blocks, San Francisco's $2 billion transit terminal is open. This is after nearly a decade under construction.
Don't you think it sounds more like someone talking on TV, right? Saying the news? This is because it was trained with someone that talks like that, okay? So we can model speaker styles, but now with neural TTS we can also model emotion and make Alexa more expressive. This is a very short example that I brought you here of a technology that I think we refer to it as DJ style, which is basically allowing Alexa to tell you what the song is about, who's the author of the song, etc. Like if Alexa were like a DJ or something more, someone more cheerful when it's saying that. So this is an example of adding more emotion to a very short phrase. This is probably too short, but just to give you a sample, okay?
That was the brand new single Floating by Schoolboy Q featuring 21 Savage.
So as you can see, Alexa is basically telling us what the song is about, but in a more cheerful way, okay? And this is using neural TTS. What is the next step? We can model voice styles. We can model emotion. What is the next logical step? The next step is modeling celebrities' voices.
Just like we practiced. Ready?
I'm always ready.
Showtime.
Today in Los Angeles, it's 85 degrees. Say my name. Woohoo! Oh, aren't we organized? I'm not reminding you of it.
Not bad for a rookie.
Say rookie again. I dare you.
I think this was a good choice to start with Samuel Jackson. We are not only recording jokes or laughs, etc., we are creating a neural network model of Samuel Jackson's voice. So basically that means that you will be able, when this is out, this is not out yet, you will be able to tell Alexa to speak like Samuel Jackson for everything Alexa says, okay? So let's move to for me, the best part, okay? So we are trying to go from transactions to conversations. You guys have Alexa, you probably say turn on the lights or do something, do this, do that, but it's more like a command, okay? Like saying something to giving an order. We're trying to move more into conversations, okay? And trying to provide more intelligent, more meaningful conversations. So one of the very important points about having a conversation is understanding what the goal of the speaker is. When you are starting a conversation with someone, you probably know what is the direction of that conversation, okay? Where that conversation is going. So we want Alexa to have the same kind of intelligence, to understand where Alexa is going, and we call that Laden Row of Detection. Let me give you an example. A user might start by asking for tickets for a specific movie, right? And then the user might say, okay, I want to find a restaurant, open this skill, for example, to find a restaurant, and also open the Uber skill to get me a cab. But basically what the user wants to do is a night out. The user is organizing a night out. They want to go to the movies, they want to have dinner, they want to come back home, etc. So what if Alexa could actually detect that, and try to be more intelligent and be more proactive at suggesting the next steps in a conversation, okay? So this is a demo that Rohit Prasad, our head AI scientist, showed in REMARS, which was a conference in Vegas. And I want to share this with you. It's basically recorded from his presentation. I don't have the actual video, but I wanted to share this with you. It's called Alexa Conversations, and it's a way to make different skills interact seamlessly as part of a conversation. The user is not saying open this skill or open the skill. Basically, these are skills that are working together to provide that night out experience. Okay? Let's take a look at it.
Alexa, what are the showtimes for Dark Phoenix on Saturday after 9 p.m.?
Here are the showtimes for Dark Phoenix on June 8th after 9 p.m.
Give me 2 tickets for 10:35.
Okay, 2 adult tickets for the 10:35 p.m. show of Dark Phoenix on Saturday, June 8th at Regal Cinnabar Palace Station will be $21. Should I book the tickets?
Wait, how long is it?
Dark Phoenix is 1 hour and 52 minutes long.
Actually, what are the showtimes after 7 p.m.?
Here are the showtimes for Dark Phoenix on June 8th after 7 p.m.
Give me 2 tickets for the 7:05 show instead.
Okay, 2 adult tickets for the 7:05 p.m. show of Dark Phoenix on Saturday, June 8th at Regal Cinnabar Palace Station will be $21. Should I book the tickets?
Yes, please.
You will receive an email from Adam Tickets with your tickets. Will you be eating out near Regal Cinnabar Palace Station?
Yes, find me a Chinese restaurant.
Here are some Chinese restaurants near Regal Cinnabar Palace Station.
Tell me more about Mach 32.
Here's more information about Mach 32.
That looks good. Give me a table at 6 p.m.
Okay, you'd like a reservation for 2 at Mach 32 at 6 p.m. Should I book it?
Sure.
You will receive an email from OpenTable with the details. Would you like a cab to Mach 32?
Yes. Get me an Uber.
Sure. I'll get you an Uber X for 2 from home to Mach 32, which will cost about $8. Is that okay?
Sounds good.
Your Uber X will pick you up at 5:42 p.m. Anything else?
Show me the trailer.
Now playing the trailer for Dark Phoenix.
Ladies and gentlemen, now send us Charles Xavier. Help is on the way.
So in this video, we saw a lot of the things that we talk about today. We talked about context awareness. For example, in the last part, the user says, show me the trailer. The user doesn't even have to specify what movie we're talking about. We are maintaining the context. We are seeing Alexa being more proactive. Like if you saw the video carefully, you saw that the Alexa suggested to get a cab. You know, basically that was a proactive way to suggest opening a new skill. And in here, you see multiple skills interacting together as a seamless process. Okay, so if you pay close attention, you saw probably like up there at some point different brands, right? Those brands were the skill brands. Okay, the skills that were being invoked basically automatically to provide the specific service that the user is interested in. So this is a glimpse at what's coming, at the next steps. More intelligent conversations, more human-like level of reasoning. And I have a final slide that I wanted to show you before we go into Q&A, which is this. When we started in 2014, we got really good at phenomena modeling. Phenomena modeling is ASR, NLU, all the initial core technologies that I mentioned, right? But now we're doing great progress into having Alexa make more intelligent decisions, making decisions for you that make sense, and they are what you really want to do, and reasoning, starting to reason about what really is going on here, what the user wants to do, what's the latent goal for the user, okay? So we are going into autonomy little by little, making Alexa more autonomous, okay? But unfortunately, the promise of an artificial general intelligence, or AGI, is outside this stack. We're not even close, okay? So don't get your hopes up just yet. But I hope we will get there sometime. So thank you very much. This is it, and we go into Q&A, okay?